g of x is defined by e to the power x minus 1, where x is less than 1, and 5 plus x, where x is greater than or equal to 1. We're going to sketch this. So first, let's do the exponential. I'm going to start by just drawing e to the power x that I know has an asymptote at y equals 0. I know it passes through the point 0, 1. So it's going to look something like this. Then I know that if I have a minus 1, that's going to move down 1 square in the y direction. So I'm going to take this whole graph, I'm going to move it down 1 square. So it's going to look something like that. And let me adjust that. The asymptote is now y equals minus 1. And it's now going through the origin. So this is the graph of e to the power x minus 1. But it should only be valid for where x is less than 1. So it's only valid for this part of the graph. So I'm going to rub this part of the graph out. And I'm also just going to use a hollow circle there where x is equal to 1, because I know the exponential function is not valid at that point. Next, 5 plus x, where x is greater than or equal to 1. So when x is equal to 1, 5 plus 1 is 6. Draw a solid circle because it is equal to, x can equal 1 at that point. And then when x is 2, we'll get 7. When x is 3, we'll get 8, and so on. So we've got this straight line. Part B states the range of g of x. So that's the y values. So let's look at the y values. I can see that my graph is going down towards minus 1 down here. It will never touch minus 1. So I'm going to say that g of x has to be greater than minus 1. You can't equal it. Then I can see it goes up towards the value here, whatever this value is, that I don't know right now. But I do know that's where x is equal to 1. So if I substituted 1 into my exponential function, I get e to the power 1 minus 1, which if I was to write that as a decimal, I'd get 1.718-ish. But to be exact, I'm actually just going to leave it as e to the power 1. So far I've explained that g of x could be between minus 1 and e minus 1, but not equal to either of those values. It could also take any of the values at the top here, though. It could be anything greater than 6. So I need to also include that. G of x is greater than or equal to 6. So the range of g of x is, it's greater than minus 1 and less than e minus 1, or it's greater than or equal to 6. Part C finds g of 3. So when x is 3, I'm going to be using the linear graph. So we'll have 5 plus x, so 5 plus 3 is 8. So g of 3 is 8. G of minus 1, when x is minus 1, that's less than 1, so we're going to be using the exponential graph. So we'll have e to the minus 1, And again, if you were going to use that as a decimal, you'd get minus 0.63 to 2 decimal places. But I'm going to leave my answer like that because that's exact. Part D. Solve the equation g of x is equal to... that's a typo, that should say 9 there. Solve the equation g of x is equal to 9. So looking at my graph, I can see there's only one point where my graph is equal to 9, and that's from the linear function. So if I say 5 plus x is equal to 9, so that's when x is 4. Alternatively, you could have just read that from your sketch. And then part E, solve g of x is equal to 1. Again, I can see there's only one point where my graph is equal to 1, and that's when the exponential, the e to the power x minus 1, is equal to 1. So if I add 1 to both sides, I get e to the power x is 2. Taking logarithms of both sides, so x is ln 2. And I'll leave my answer like that because that's exact.